Good morning to one and all. Myself, Professor Prashant Mahajan, working as an assistant professor at I.S.E Institute of Information Technology. So today we are going to see the topic ion selective electrode from the unit instrumental methods of analysis. So already we have seen glass electrode and calomel electrode. The third part is ion selective electrode. So ion selective electrode, the name itself indicates that the electrode is specific for a particular ion. Means what? If the ion is H plus selective, then that membrane is called as glass electrode. If it is selective for calcium, then it is called as calcium ion selective electrode. So the definition is given. So you can see the definition, that is a membrane of a half cell is sensitive to particular ion in solution, and ion exchange take place between the membrane and the solution containing specific ion and develops a potential which depends upon the concentration of that ion. Means what? We are having two solutions like that, solution 1 and solution 2, and in between that we are having membrane. So this difference between the concentration of the solution 1 and solution 2, it is measured by this membrane. So that will be the ion selective electrode. So you can see the definition again. In this electrode, a suitable non-porous membrane separate the two solutions containing same ion of different concentration. Potential is developed on both sides of the membrane. So here is the potential is going to be developed, and here. So this is ion selective electrode. So ion selective electrode detects and measure the concentration of the ion in the solution. So some advantages are given for the ion selective electrode. So first, it is mechanically strong. That means it can be used for wide range of temperature. Second, it is resistant to the solvent attack. That means it can be used for colored and turbid solutions. Third point, resistant to chemical attack means it will not get dissolved in the chemicals. And last, conductor through ion exchange. So that are some advantages of ion selective electrodes. So there are five types of ion selective electrode based on the type of membrane. So first is glass membrane electrode, so which we have already discussed in the previous lecture. Then solid state membrane electrode, then liquid membrane electrode, gas sensing electrode, and last is enzyme based electrode, that is also called as biochemical electrode. So first, that is glass membrane electrode. It is similar to the glass electrode which we discussed in the previous lectures. So in that we are having only that Li glass. Instead of that we are having Na glass. So that is the only difference. Remaining part is the same. So it is selective for H plus ions. So this is, you can see, that is internal solution. It is of HCl, and this is a glass bulb. So we are going to dip this glass membrane electrode in the solution of HCl. So this HCl internal solution is having different concentration, and other solution which is present in the beaker which is having different solution. So the potential is developed at the this membrane, and which is recorded by this wire. So that is your first glass membrane electrode. Then second is, so this is already over in the last lecture. So the second is solid state membrane electrode. So in that we are going to see first, that is fluoride ion selective electrode, and second one is chloride ion selective electrode. So what happens in that? So we are going to see the membrane is made up of lanthanum trifluoride crystal, which is F minus ion electrode doped with europium fluoride. So that means lanthanum fluoride is doped with europium fluoride. That means here is 3 fluorine, here is 2 fluorine. So there is a vacancy of 1 fluoride. So you can see this single crystal of LaF3 with EuF2, it is at the bottom, and which is acting as a membrane for transfer of fluoride ions. Then this internal reference solution, it is of sodium fluoride and sodium chloride, and this is the internal reference electrode. So we are going to dip this electrode in the solution containing fluoride ions. So here is a one fluoride. So you can see here is one fluoride solution and other will be present in the beaker. So there is a difference in the concentration which is recorded by this wire. So you can see the crystal is sealed at the bottom of the container. Above it there is an internal reference solution that is of NaF plus NaCl or K plus KCl and the reference electrode which is already I have mentioned. So you can see the working. Europium fluoride produces hole in the crystal lattice of lanthanum fluoride through which fluoride ion can pass. So that means this will be creating hole in this like that this one and fluoride minus ion can move from it. When this electrode is kept in testing solution containing fluoride minus ion, the potential develops due to the differences in the concentration of two solutions. So we are having two fluoride minus ion solutions. One which is present in the beaker and second which is present in the internal reference solution. Then limitation is there. So you can see it is 100% selective for F minus ion and it is only interfered by hydroxide ion. Hydroxide ion it is basic. So which will react with the lanthanum and produce or form lanthanum hydroxide. So it is basic. So we have to maintain the pH at neutral. So what we have to do? So we have to add acidic buffer solution. So you can see with the consequent release of extra fluoride minus ion. This interference can be eliminated by adding pH buffer to the sample to keep the pH in the range of 4 to 8 and hence ensure the low concentration of OH minus in the solution. So if OH minus is present in the solution, that will form lanthanum hydroxide and that will release three fluorides. So you can see here lanthanum fluoride, hydroxide will react with this lanthanum and it will release three fluoride minus ion. So that will interfere in the reading. So to reduce this, we have to add pH buffer. So that will maintain the pH of the solution in the range 4 to 8. So that is called as solid state membrane electrode in that fluoride ion selective membrane. Then next is chloride ion determination. So you can see at the bottom there is a palette electrode filled in the position with epoxy resin. So there is internal electrolyte, reference electrode is there and Kaplan body is there. So you can see what is palette. So this palette is made up of silver sulfide and silver chloride. So palette it is formed by using these two compounds. The electrode is made up of Teflon and the palette is attached using epoxy resin. So it is shown here this palette is attached by using epoxy resin and this electrode it is made up of Teflon body. So when the electrode membrane is in contact with the solution containing chloride ion as electrode potential develops, the potential is measured against the constant reference electrode. So what you have to do? Just you have to dip this electrode in the other solution of different chloride ions and there will be a potential develop and that potential develop it is measured by this internal reference electrode. So that is called as chloride ion determination. Then third one is gas sensing electrode. So these electrodes are useful to analyze the gases like ammonia, NO2, SO2, carbon dioxide and hydrogen sulfide. So means this electrode is particularly selective for analyzing gases. So for example, a nitrate ion selective electrode is for only nitrate. A sulfide ion selective electrode, it is for only sulfide. So what is the mechanism? So you can see in the diagram at the bottom, there is a gas permeable membrane. So this is a gas permeable membrane through which gas goes to the internal solution and it will change the pH of the internal solution. So the change it is measured by this internal electrodes. So you can see what is that gas permeable membrane. The microporous membrane is hydrophobic porous polymer made up of polypropylene or any other fluorocarbon which allows only dissolved gases to pass through. So it will allow only dissolved gases. Then the electrodes Ag and AgCl and glass pH electrode are dipped in the internal solution. So it is dipped in the internal solution. The electrode does not detect the presence of molecular gas, but rather an ion into which the gas is converted after it passes through membrane. So it will detect only ions and not the molecular gas like NH3, NO2. So we have to convert that gas into ions. So working is there. You can see electrodes including the ammonia ion selective electrode. So what we have to do? Use a gas sensing mode of operation. So for detection of ammonia, what you have to do? So you can see a caustic solution is added to the sample solution to liberate ammonia. The gas penetrates through a membrane and changes the pH of the filling solution. The change in the pH is proportional to the ammonia concentration. This gives a quantitative measurement of ammonia in the sample solution. The boundary potential formed due to the difference in the concentration of ammonium ion is measured with the help of reference electrode. So as I mentioned earlier, we are not going to measure the electrode potential of molecular gas. We are going to measure it for ions. So this will pass through this membrane and that is called as gas sensing electrode. So this membrane, it is made up of polypropylene or fluorocarbon. So for that we have to add caustic solution in the sample solution that will liberate ammonia and that will pass through the membrane, that will change the pH of the solution, and that change is directly proportional to the concentration of ammonia. That is the ammonia ion selective electrode. So that's it from today's lecture. Thank you.